Hi, welcome to C# Best Practices. This course is all about writing better code. We want to create better structures and make our code more readable and more maintainable. So we're going to give you a number of tips and tricks and a little bit of architectural guidance in order to help you create better code that has fewer bugs and causes you less problems in the long run. No one really likes to support code. Everyone likes to create code. And if you can create better code from the start, you have less support. So that's really the goal of this course, is to give you some guidance in helping along with that. We also provide a little bit of guidance to help you get along with your teams. And that's one of our first best practices topics is code style. Code style is essentially the way you format your source code. And that doesn't really have anything to do with the actual execution of the code. It's just about how to make the code more readable. And in particular, this topic comes up a lot when working with teams, because people have different styles. The important thing is to agree on general styles that everyone can get along with. A lot of times organizations will come up with very detailed code style manuals, and they're very rigid, and that causes a lot of friction in teams. So we're going to give you some guidance, but again, it's guidance, as opposed to hard and fast rules. We'll also talk some about architecture, and we'll be talking about some object-oriented principles as well. And then we'll get into a little bit of tips. So we'll spend some time on code style, probably too much time. It's one of those things that developers seem to spend a lot of time on when they could be doing things that are more productive. Then we'll get into some things that are more productive, the solid principles. And these are some basic object-oriented principles that if you're familiar with object-oriented programming, they should come naturally to you. But it's not a bad thing to have a reminder and a little bit of a checklist in your head when you're actually starting out a project. And then we'll have some general best practices, and we'll go through a number of different topics in those best practices. We'll spend a little bit of time in particular on exception handling. Exception handling is one of those things that people don't like to deal with. Of course, all of our code runs perfectly, so we don't actually need to handle any exceptions. This is a complete fallacy. We do need to handle exceptions, and we also need to have our code avoid creating exceptions when it's possible. We'll also get into Lambda Expressions and LINQ, or LINQ, and we'll talk about those because those are relatively well-adapted Microsoft technologies, particularly in ASP.NET in the MVC pattern. And we'll also talk about async methods. Async methods are a nice, easy way of handling threads. So we'll talk a bit about that. And then we'll get into some architectural patterns, and we'll talk about 2-tier and 3-tier and some of the other basic patterns. And we'll spend a little bit more time on the model view controller pattern, and in particular, how it applies in ASP.NET. ASP.NET MVC is really the preferred pattern at this point for web forms. So we'll be talking about that, and we'll talk about best practices in using that pattern. So we've got a fair amount to cover, and it is a nice short course for you. So we're going to try to pack a lot into a relatively short amount of time. Let's get to it. To begin our best practices, let's talk about code style. So when we talk about code style, what are we really talking about? We're actually talking about source code conventions, how we name our variables, how the code is laid out, the commenting, and basically how the source code looks and how we as developers work with it. Now, there are a lot of fights and arguments about code style when it's rigidly enforced. So why do we have a standard anyway? Basically, the same reason that we have those fights and arguments. Developers have individual and conflicting preferences. And if we let developers and a team all put in their different preferences, we have source code that looks completely inconsistent and is very difficult for other developers to go and grab someone else's style and figure it out. It just becomes a maintainability problem. Whereas if we have some sort of consistent code base, developers know where to look, they know what to expect, they know the conventions, so it's much easier for one developer to pick up another developer's work and not be confused by the code style. There are other things to be confused about. One thing I would say before we go too deep into all of this lesson, don't be too rigid with the code styles. I'm sure that a number of us have dealt with organizations that have extremely rigid coding standards. And I've worked in one of those as well. We essentially had a code style that was designed so that you could put source code on a tablet-sized screen, so that none of our methods could have more than, say, 15 lines. They could not be 80 characters wide or more, And there were all sorts of other really nitpicky things. It drove us all crazy, and they were rigidly enforced in code reviews. We spent a lot of wasted time on that standard, and we all kind of rebelled against it. That's not what you want from a standard. What you really want from a standard is for developers to agree on common practices so that they're all on the same page. This should not be something that you have to fight about. This should be something that we all agree to and want to do because it makes our lives easier. In the coming slides, we're going to have some, in quotes, rules. These are not necessarily my rules. They come from a variety of sources, including Microsoft, which of course changes their standards as time goes by. But don't call them rules. These are some suggestions. And I'll give you a little bit of an argument as to why I think they're the right thing to do. But they may not be the right thing to do in your organization or your practice. The important thing is that you do have some sort of standards and that everybody knows what they are. So let's talk about naming conventions. .NET came out with a naming convention for classes, public properties, methods, and events called Pascal casing, which means the first letter is uppercased, and then each first letter of each word in a variable name or a class name or a property name is also capitalized. For method parameters and local variables, we use camel casing. And in camel casing, the first letter is lowercase, and then the first letter of each word is uppercased. So it's like Pascal casing, except the first letter is lowercase. And now private and protected member variables. And here's where things get a little bit more troublesome. The last two were pretty much .NET standards, and I think everyone pretty much follows those. The private and protected members has changed over time. Right now, the recommendation is to use camel casing. But there's also a recommendation that says, well, you could use underscores if you wanted to as well. So we have underscore and then Pascal casing for the member name. What they're very sure of these days is that you don't want to use Hungarian notation, which gives you a type indicator and then followed by a variable name. So in this case, I have the type indicator for a string, str, and then my class string. That used to be a Microsoft standard, but they've gone completely away from that now because we have IntelliSense, so we can float over the variable and get the name of the class. Well, that's great if you always use a Microsoft editor or something with IntelliSense. Maybe not so great if you don't. I don't love camel casing because in that case, I don't know whether my variable is actually an overall class member or if it's a local member or a parameter. This is one of those things that you should discuss with your team. Constants aren't particularly controversial. In general, the standard is camel casing. In the old days, it used to be all uppercase with underscores. Of course, that's really hard to type, so that's not that much fun, but it certainly let you know that something was a constant, whereas the camel casing really doesn't let you know that. The old C, C++ convention is definitely out of favor, so I wouldn't recommend going with that. Now, previously I told you that these were recommendations and suggestions, not rules. I'm going to make an exception here. This is a rule. Make your variable name clear and meaningful. I actually had an interview once where it was a test question and they hid all the variable names. They just used abbreviations and letters. And it was so hard to read the code that I actually had a great deal of difficulty with the test. When they showed me the real code that had real variable names, all of a sudden everything was completely clear to me. That was the difference that clear and meaningful variable names means. Also, avoid abbreviations, except really, really common ones, such as ID or FTP or HTML. These days, we don't really have to worry about the length of our variable names, so make them completely clear and don't allow any confusion. And we're supposed to use Pascal casing for abbreviations, so HTML is capital H, lower TML, as opposed to all uppercase HTML. And we're hoping to not use underscores, except of course, if it's the first underscore of a member that we talked about before. At least I get a little bit of a win here because I don't like to type underscores, so we're not supposed to have hard underscore to underscore type underscore name. These next conventions should be pretty obvious for anyone who's dealt with object-oriented programming. Class names should always be nouns, because classes reflect nouns. Also, property names should be nouns, again, because properties should be nouns. And method names also should be verbs, because method names imply some sort of action that's going on, so they should be verbs. By the way, if you find yourself breaking those rules, you might have some kind of architecture or design problem there. For interface names, you just prefix them with the capital letter I, and then the next letter is also uppercase for Pascal case. And namespaces. It's very helpful to use the using statement. So up at the top, you put in using system.drawing. Instead of having within your code system.drawing.color, color is equal to system.drawing.color.red. It simplifies your source code a lot more if all you have to say is color is equal to color.red. It's a lot fewer characters, and it's a lot easier on the eyes, particularly when the namespaces get really long. System.drawing is actually a pretty short namespace. A lot of times you end up with ... with a whole lot of namespaces within. Okay, so that was a lot about naming conventions. We're going to take a short break here, and we'll come back and talk about type declarations. Okay, let's continue talking about code style, and we'll talk about type declarations. The recommendation is to use predefined types instead of system types. So you use int instead of the system type int32. Use the lowercase string instead of the uppercase string. And you use bool instead of boolean. They actually both mean the same thing, but just pick a convention and stick to it. And Microsoft's recommendation is to use the predefined types. And now the keyword var, and this is an interesting one. My personal preference is I don't like var, but I'll give you the reasons why other people believe that I'm wrong. The biggest reason that I've seen is that it helps with readability, because if you have those really long types, then it gets to be a whole lot of visual clutter. I would argue that to some extent, having the using statement remove the namespace from the type name helps that readability. But of course, there are really long class names as well, and that's the point of var, is to eliminate those. There are also rules that go along with the use of var that indicate that you really need to be able to tell the type in the var statement. So if you have var variable name is equal to, that equal to should really tell you what the type is, so you don't have to guess. I see this rule violated all the time, because the var typically is equal to some sort of expression that uses a method that has a return type, in which case you're dependent upon IntelliSense. I really don't like my source code to be totally dependent upon IntelliSense, so I try to avoid using var. I am actually in the minority in that. Have your team talk it out, make a decision, and be consistent with it. For organization, put only one class or interface or enum in a file. Try to avoid putting in multiple classes in a single file. It makes things confusing for other people when they try to find a class definition. And it's really good if the file name is actually equal to the class name. If you need to rename the class, you can rename the file, and Visual Studio will ask you if you want to refactor and rename that class name throughout the solution. Also, F2 will do a refactor rename, and that's your friend as well, because it will take care of all the references. For namespaces, the recommendation is for the namespace to follow the format company.assembly_name, .folder, .subfolder, if there are such. Again, this is one of those things that your team can agree on as to what their format wants to be. And this is another good controversial topic: how to work with curly braces. The Microsoft recommendation is for the curly braces to be vertical, so that we have that opening brace on a new line after the method declaration. Java, of course, has that opening brace typically on the line of the method definition, but C# prefers the vertical orientation. It makes the code longer, and some people will argue that they don't like the length. Other people will argue that it's easier to see code blocks that way. The other choice is what's known as Kernighan and Ritchie style, which originally comes from C and C++, and that has that opening curly brace on the same line as the method definition. And this is one of those things that, again, you want to be consistent on. Please don't mix these, because it makes the code really confusing to read if you have a mixture. Just pick one and stick with it. And if you're on the losing side of that argument, just work with it, you'll get used to it. And member declarations. We actually had a very long discussion about where members should be declared. Basically, we all agreed that they should either be on the top or the bottom of the class, but there was much discussion about whether it should be the top or the bottom. In the end, just make an agreement, and one of the arguments for not putting them on the top is they take up all the room in the top of the class. Put them within a region, and then collapse that region. And then they won't take up all the space, but they'll be there so you can see them. If you put them in the bottom, still put them in the region, and that helps clean up the code a bit. With event handlers, there are two methodologies. One is the old traditional one that came out with the original C# and .NET code, where you would have a click event and you would create a new event handler and pass in the name of the method for the delegate. And then later on in the code, you would actually have that method body. You can now use a Lambda expression, and we'll talk about Lambda expressions later on in the course. So you can put that code in line with the click event. And that code within the click event can actually be a method name. So you could still run the basic idea of the old traditional version. And that's preferable if there's a lot of lines of code there. But if it's just like a short one-liner, in that case, the Lambda expression is a bit handier and cleaner than having a separate method for one line of code. But again, this is one of those things that you'd like to agree with your team as to how you're going to handle it. So these are some guidelines for you to work with, and they're a starting point. I certainly don't think that you should take these without taking a look at your own styles and the other members of your team, if you have a team, and their styles. The important thing is that you have consistency among yourselves and agreement among yourselves. Nothing is more miserable than having one person write up standards for everyone without any kind of discussion and enforce them rigidly. It makes for a really bad dynamic. Take these as a recommendation and work out your own. Solid principles are some basic principles of object-oriented programming that can really help you when you're designing your applications and maintaining your applications. If you can remind yourself of these principles, you'll save a lot of headaches for yourself in the coming years. Solid principles are 5 basic principles, one for each letter in solid, and they're intended to enhance dependability and maintainability by basically simplifying things, decoupling things, and lowering the overall complexity of an application, and in particular, the classes that comprise the application. Robert C. Martin is the first one who's credited with coming up with these principles, and you can see that link where you can get the original paper, which is over a decade old at this point. He's also written a couple of books on agile development. So what is solid? These are the 5 principles. The first is single responsibility, and we're going to be talking about each one of these principles in detail. The second is open-closed principle. The third, the Liskov substitution. The I stands for interface segregation, and the D stands for dependency inversion. Single responsibility, in my opinion, is probably the most basic of the principles. It's also likely the most important, and probably the one that gets violated the most. It simply states that a class should have a single responsibility. That responsibility should be entirely encapsulated by the class, and all of the services of the class should be narrowly aligned with that responsibility. So what does that really mean? What that means is when we're creating a class, we only want it to do one thing. We want it to do that thing completely, and we don't want it to do anything else. And this is where it gets really hard, because as time goes by, we often add these little features that add to the class, but they don't quite fit with the rest of the class's original responsibility. So the class expands in terms of its responsibility, and also it correspondingly expands in its complexity. We're going to talk about expanding classes in another principle, but it does feed back to the idea of a single responsibility. So for example, we have a customer class, and our customer class is going to be your basic data layer business object kind of class. It's going to interact with the database for creating, reading, updating, and deleting, basic CRUD operations. So that's what it should do. It should present that interface and just that interface. It should not in turn manage customer orders. Should not be doing any kind of operations for orders, querying for orders. That's not the responsibility of the customer class. It should also not provide helpful user interface methods. It certainly should not be outputting HTML that gets sent out to a web page as a way of helping things along. That's another class. And it should also not log exceptions. Now, this is a little bit interesting. You might say, well, it needs to handle exceptions, which is absolutely true, but it should not be doing the logging. It should communicate with a logger class to do that sort of exception logging. Again, the customer class has a single responsibility, and it should be focused on that responsibility. The next principle is the open-closed principle. And this is somewhat related to the single responsibility. It just kind of takes it through time. The open-closed principle says that software entities, classes, modules, functions, whatever, should be open for extension, but closed for modification. What that means is that we should be able to extend our entities, but we shouldn't be modifying them. And the best example we have in C# is inheritance. When we create a class, we want to extend it by using inheritance. We don't want to modify it to add features. So we want to allow its behavior to be extended without modifying the source code. So we do have to think when we construct the class, what should be public, what should be protected, and what should be private, in order to help with extension, but not go too far. They nicely allow us to do modifications to correct errors. That's a good thing. However, any new or changed features are going to require a new class. We don't want any feature creep in our original class, and we can create those new classes by inheriting from the original class. A lot of times, by the way, we'll talk about these principles in terms of how we violate them. I've tried to balance that with how we can actually work within them, but so often we're really talking about don't do this as opposed to do this. So we're going to have our user class, and this is one of those don't do's. And the user class supports multiple user types. There's an admin user, member user, and guest user. And you can imagine there's going to be a public property or something like that to set the user class type. And the behavior, of course, is going to be a little bit different for each type of user. They may support different views, they may have different roles or permissions, but it'll be a little bit different depending upon the type of user. You may well imagine then, in a get of a property, that there may be an if statement or a switch statement, depending upon what the user type is, whether it be admin, member, or guest. And the output of that get routine is going to be different depending upon the user type. So what happens if we add a user type? We have to change code in the class. We'll be adding a feature, and we're changing code in the base class. So that's a violation of the open-closed principle, in particular, the closed portion of that. So instead, each one of our user types should actually be a class unto itself, and they should inherit from a user-based class. So I'll have that user-based class, it'll be all closed up. An admin class will have responses that are appropriate for admin, a member will have appropriate responses and methods for members, and a guest will have their appropriate responses. So we won't use just one class. If we need a new user type, then we just create a new class that inherits from the user-based class. So that's enough for right now. We'll take a break, and we'll come back with Liskov substitution principle. So let's talk about the Liskov substitution principle. The Liskov substitution principle, or LSP, is basically strong subtyping. And this is something that we really don't think a lot about in C#. It's a little bit built into the language feature. But it's just a principle that you should be aware of, and we'll talk about an example of how you can not be aware of it on occasion. So S is a subtype of T, some class S, and it's going to be inheriting or implementing an interface of a class or an interface T. The Liskov substitution principle says that the objects of type S may be substituted for objects of type T. So any method or parameter or class that's going to use an object of type T will also be able to use an object of type S, and nothing bad will happen. The substitution will not significantly alter the behavior of the program in terms of its correctness or its overall task performance. Obviously, if you're going to be working with different subtypes, there is going to be a little bit of a behavior change depending upon the particular subtype, but that's intended. What we're talking about is we're not going to do anything bad that alters the application. We have those user classes from our earlier example, the admin user, the member user, and the guest user, and they inherit from user. So in our previous terminology, user is the class type T, and admin, member, and guest user are the subtypes S. So each one of those user subclasses must fully implement the user class interface. In particular, we don't want to see any not implemented exceptions, because obviously that's going to cause a problem for the application. Client of this user type is going to treat it like a user, run a method, and expect it to be implemented, and it will throw an exception because it's not implemented. That's not good. So we can't have that. And that's the basic idea behind the substitution principle. The interface segregation principle is basically a simplifying principle. It states that no client should be forced to depend on methods that it doesn't use. And what this turns into is splitting large interfaces into smaller, more specific ones. They're more focused on particular client roles. So the clients will only have to know about the methods that are of interest to them, and therefore we can have some roles. So when you've gone into .NET and maybe you've had classes that have implemented multiple interfaces, that's an example of interface segregation. Of course, all of those things could be combined into one, but a lot of classes wouldn't use all of those interfaces, and it would be a bit of a mess, and they would have to figure out really complex interfaces with lots and lots of methods. So splitting the large interfaces into smaller, more compact ones makes your code easier to refactor, change, and redeploy. It also makes it, in general, more understandable. So we're going to go back to our user classes again, and we have our base class user, and we have those subtypes. Our user interface should not include methods that are specific to the admin user, because the member and guest classes don't need them. So in that case, you would probably put in not implemented, which would not be good, or they just wouldn't implement that interface. So we split the user interface into perhaps two interfaces, one for admin and one for the other users. Or maybe we really need three, one for admin, one for member, and one for guest user. So we end up with an iUser interface, which has the basic methods, and an iAdmin user, which has the admin methods. And then we have our user class that implements those two interfaces. Dependency inversion is our last principle, and in terms of thinking, it's a little bit abstract, so stick with me on this. What it states is that high-level modules should not depend on low-level modules. It also states that both should depend on abstractions, so there shouldn't be any interdependence, and the abstractions should not depend on details, and the details should depend on abstractions. So what we're really saying is that both the high and the low-level objects must depend on the abstraction. And that way, those two objects are not coupled. It's basically an inversion of thinking. Quite often we think of high-level modules being parents and lower-level modules being children. And the high-level modules, therefore, understand who their children are, and we try to make sure that the children don't know anything about the parents. What this principle is really saying is the parents don't know anything about the children, and also the children don't know anything about the parents. But they do know something about a common abstraction. So here's a little bit more of a concrete example. Back to our original user class, and we want to be able to log exceptions. Now, we've already talked about this. We don't want the user class to log exceptions directly. So we're going to use a logger class. We'll just create ourselves a logger class right anytime we have an exception, or maybe we'll make a method that says handle exception, and it will create our logger class. We're done. Moving on. Well, wait a minute. Our logger class has multiple types. It can be a file logger, a database logger, or a Windows event logger. And we followed a previous principle and made different class types for each one of those loggers. That means our user class has to know what kind of logger it should use, whether it be file, database, or Windows event, and it should create that particular type of logger. Well, if we get back to our S principle, our single responsibility, that seems like a whole lot of work that user class has to understand. Seems out of scope for a user. It also violates our dependency inversion. The user class has to know way too much about the logger class in order to make that decision. So instead, the simplest solution is that something else that understands what should be done passes a logger object to the user class, and the user class uses it as a logger, as opposed to a specific logger type class. And the factory method pattern allows us to create a logger of a given type. So the user class could also use a factory that creates a logger of a given type without the user class having to know what kind of type that is. It might get pulled out of a configuration file, for instance. So that's the basic idea behind dependency inversion. Different classes shouldn't really know a great deal about each other and shouldn't work very hard to figure it out. And those are the solid principles. And if you can think about these things when you're first creating your applications, it'll help you downstream avoid really nasty interdependencies that create bugs. It'll also help your application grow, particularly if you think about them when you're adding features. And try not to violate a principle while you're adding the feature. It's really easy to violate those principles because in some ways it's a shorter path. But in the long run, it'll end up biting you because later on, as the application matures and you add more and more features and your classes grow and grow, you're adding more and more complexity that becomes interrelated between the classes. And that's where some nasty bugs can come up. So following solid principles is a nice discipline to get into, and although it may cost you a little bit of thought time up front, it'll be worth it in the long run. In the next few lessons, I'm going to be talking about general best practices. We'll essentially be going through a number of different areas, and we'll be talking about how you can structure your code so that it performs better and is a little bit more maintainable. These, of course, are just guidelines and not hard and fast rules, but they're things for you to think about when you're creating your code. So just in general terms, you want to simplify your code. You want someone else to be able to understand your code. You, of course, don't want to support your code forever. It's nice that it would live forever, but you don't want to be stuck in support of that same code base for the rest of your life. So you don't want that someone to come back time and time again to ask you questions about this complex spaghetti code. You want them to be able to understand it because it's readable and maintainable. And when I talk about simplifying code, simple doesn't necessarily equal fewer lines of code. You can write elegant, beautiful code that doesn't use many lines of code. However, it's very difficult for someone to understand. It may be because of the levels of abstraction and complication that you've got in it, and it's beautiful code, but someone who's out of school for 2 or 3 years just won't get it. When I was interviewing people for jobs, one of the things that I used to have them do was bring in some code that they were proud of. And a guy who had a number of years of experience came in, and he had some very, very sophisticated code. And we went through it, and it was extremely well done. And I asked him, would someone who was 3 years out of school understand this code? And the answer was no. Well, we didn't do too well from there because the corrective action wasn't particularly good either. But that's the problem. Really beautiful, elegant code isn't necessarily maintainable by the level of people that you want to support it. So try to keep that in mind, that you don't want to be the one who owns this code base for forever. You want to write it for someone else. So you want to avoid the latest tricks of the day. Methods should only do one thing. This should be somewhat obvious in object-oriented programming, or really any programming. But you don't want to have really long methods that do a whole lot of things. And we talked about a pattern that addresses that as well. You also should be consistent with your naming conventions. And we've had a lesson about naming conventions, so I won't beat that dead horse anymore. And when you're constructing your applications, think about the classes that you're going to create and the design patterns that you might be able to take advantage of. A well-constructed application will be easier to maintain. Try to use properties instead of public variables. Properties will give you access methods, the getters and the setters. And that allows you to use validation in the set method, or perhaps threading support in the get method by using locks. Now, if you just have a get and a set that doesn't do anything else, the performance is roughly the same as a public variable in .NET. It's compiled to be so. But the getters and setters allow you to expand that code if need be, so it adds some flexibility there. Also, you might prefer to use runtime constants versus compile time constants. The difference between a read-only, which would be runtime, or a const, which would be compile time. A runtime constant is more flexible. It allows complex types. Const, however, provides better performance. Because it's at compile time, it essentially takes your symbol and replaces it with whatever value you choose. So understand the difference between those two, and you might choose runtime just for that flexibility. There are a lot of best practices associated with strings. I'm just going to talk about some of the major ones. Try to use string.format or a string builder when you're creating complex strings from multiple pieces or multiple variables. String concatenation operations create another copy of the string, so it damages performance and memory. If you're just doing single concatenations, just one string added to another string, that's okay. But if you're looping and building up perhaps SQL statements that have a number of different concatenations, then you should definitely use a string builder or a format. Also use string.isNull or empty, or string.isNull or whitespace when checking to see if strings are empty. Don't write your own. This one's personally embarrassing to me because I got caught writing my own, and a junior engineer came in and said, "Why don't you just use isNull or empty?" Oh, I didn't know it was there. Sorry. Please don't make my mistake. The Microsoft website has a lot more string recommendations and a lot of details about how the comparisons are done when you're doing different kinds of string comparisons and how that affects with locales. So take a look at that. Try to use for each instead of a for loop with an integer counter. For the for each statement, the compiler will generate optimized code for the particular kind of collection being used. A for each will also allow you to be able to change the collection type later on for maintainability, rather than having to change going from a for loop to a for each if you change the collection type and having to rewrite the loop. Rewriting the loop, of course, would give you more opportunities to make mistakes. So consider using for each in your loops. Also, try to use variable initializers instead of assigning values within a constructor. So an initializer initializes a variable value when that variable is declared. So you can see we have the public class employee, and it has a private string called name, and we've initialized it to Bob. An assignment would have the constructor public employee and say name is equal to Bob, and it would be declared above this area. The reason for this, and it's not a performance issue, it's really more of a maintainability issue. If you add another constructor override, it's possible that you might forget or miss that you also have to initialize the variable name, so that you might miss that name is equal to Bob in another constructor. Whereas if you've used the initializer, that's going to apply to all constructors that you write. So you don't have to repeat that code in every single constructor override. Also brings me to the topic of constructor chaining. Again, instead of repeating code, what you would like to do if you have multiple overrides for constructors is use one constructor that actually has the code in it. So in this case, we have an override for a new customer with no parameters, and we're going to call our other constructor that has two parameters and pass in parameter values, which are going to be our initialized values. Our second constructor takes parameters for customer ID and string name, and we do whatever we need to do with those parameters in that constructor. We don't have to rewrite that code in the constructor that has no parameters if we call or chain the constructor from the no parameters to the other override that takes the two parameters. So that's a few suggestions, and we've got plenty more in upcoming lessons. Let's continue with our general best practices guidelines. Casting is one of those things that can get you into trouble. Try to use is and as instead of doing a cast. In that first line, we have a customer object, and we're trying to cast a user into that customer class. That can throw an exception, obviously, if user cannot be cast. What we'd like to do instead is to say if user is customer, then set customer equal to the user as customer. The if obviously should protect this statement, but even if there's some problem in casting the user to a customer type object, the as will return a null as opposed to throwing an exception. And then you can handle that error later. As we'll see in a future lesson, exceptions are expensive and we'd like to avoid creating them. Using is and as is one way of doing that. Nullable types are a handy thing, particularly in mapping to database fields. And I'm not sure enough people actually are aware of them or know how to use them. So I thought I'd put that in here. So in this example, we have a nullable integer, as denoted by that question mark after the int type. You can also use a nullable keyword as well. So we have a nullable integer for our customer ID, and I set it equal to null. And then we do some code, and then we check an if statement. And if the customer ID .has value, which indicates that the value is not null, we'll get the value. And that will be the value of our customer ID, an integer value. Obviously, the else on this would indicate the customer ID is null. And this is one of the keys in dealing with nullable types, is using has value and value, because you can get in a lot of trouble if you just assume that a nullable type does have a value. You can get a lot of null exceptions if you don't check has value. The using keyword manages object disposal. So in that first part, we've got using my class is equal to some new class, and then we use that my class. And when we close the curly brace for the using statement, my class is disposed, which means it actually calls the dispose method on my class, so the resources of my class are cleaned up. It's the rough equivalent of what you see below, and using my class is equal to new my class, and put it in a try and then use a finally to call dispose. Now, of course, there's no exception handler in this try, so we're not exactly trying to catch any problems. We just have a finally that's calling the dispose. And that's why this is roughly equivalent to the using, which is definitely much cleaner code. Of course, if you need to catch exceptions, then the try catch finally pattern is what you should use. Speaking of using, it's good to implement iDisposable in your classes, and that will mean that you'll implement a dispose method. And in that method, of course, you want to free any resources that your classes have used. Implementing iDisposable in your classes allows any client classes that are using your classes to use a using block. So again, it can have a using my class is equal to a new my class, and at the end of those curly braces, your class's dispose method will be called. So implementing iDisposable is a nice courtesy to any client classes that are going to use your class. Of course, if you don't have any resources that you're going to dispose, it's completely unnecessary. But if you do have resources, like connection objects that you need to dispose or close, or perhaps file objects that you need to close, or streams, then you should implement iDisposable. Let's talk about collections for a little bit. Selecting the right type of collection to be used can be a little bit of a challenge sometimes. So here are a few guidelines to give you something to think about. Use list when you're iterating through a collection. So this is when you're going through a collection sequentially, and that's the way you want to approach it. The contains method in list is really slow. So if you're kind of doing a random access or a search, then a list is really slow, and you don't want to use that kind of collection for that type. List is really good, however, for iterations. It's much quicker than the other kinds of collections. If you are going to use contains, then maybe take a look at a hash set instead. The contains method in a hash set is tremendously faster than the contains method in a list. The downside of a hash set, of course, is that there's no defined order. So you can put objects into a hash set in order 1, 2, 3, 4, but there's no guarantee that they're going to come out in that order. So truly, you need to access a hash set by its key. You can use sorted set for ordered lists, and that also has a more performant contains method than a generic list. It's also preferable to use collections rather than arrays in a lot of cases, and the reason is you have more control over the contents of your collections because you're going to be able to use add and remove methods without having to reallocate arrays, and because you also have contains methods as well. So collections are more flexible and usable as your application adapts. It's a real pain if you've started off with an array and some feature requirement change for your application makes you go to a different kind of collection type, and you have to rewrite all of that code that accesses the array. So starting off with a collection is often a better choice just in terms of that maintainability for growth. There are times, however, that arrays are a good choice. Arrays minimize memory consumption simply because they don't have the overhead that collections do. And byte arrays are often required. For instance, when you're working with stream objects, you're going to be working with byte arrays as opposed to collections. And collections of bytes are not particularly performant. And then Microsoft has some guidelines for the types of collections to be used on public APIs. It suggests that you don't want to use weakly typed collections, that you want to use templated types of collections as opposed to just generic lists. And by generic lists, I don't mean system.collections.generic.list. I mean the actual list, like array list, that does not have a particular type. They also suggest that you don't use array list because it's weakly typed or a list of a templated type, and nor do they want you to use hash table or dictionary of templated types. And the reason is that those objects have a number of methods that they would prefer not be called from a public API, and they would prefer that that not be available, and that a lot of the methods are really for internal use. So that's their suggestion and guideline. Their suggestion is that you use iDictionary or iEnumerable instead of array list or hash table or dictionary. They also suggest that you use collection and make that available as opposed to an array list or a list. So those are some general best practices. In future lessons, we're going to talk more specifically about exceptions. Exception handling is one of those things that no one really wants to talk about. We all want to think that we'll never have exceptions. So we have a tendency to write code that doesn't have any exception handling at all, perhaps, and then maybe we'll add it in later as we catch exceptions in our testing. Of course, this is not the intelligent approach and not the way things should be done. So we're going to give you some guidelines about exception handling, just to kind of take some of the pain out of it. The first thing to know is that handling exceptions is expensive. Of course, it's really expensive if you don't handle them at all, but there are performance problems when you do handle them. So you, of course, would like to avoid creating exceptions. In order to avoid creating exceptions, we, of course, want to check our inputs before using. We want to avoid null object exceptions and out-of-index ranges and that sort of thing. And those, again, are fairly obvious, but it's something that you should think about. Another little bit less obvious thing is that we would like to return some sort of error instead of throwing an exception. And we'll take a look at some examples. First, our general form for handling exceptions. And I'm sure you've all seen this before. At least I really hope so. So we have our try block, and in that block we're going to have some code that might cause an exception. And we want to minimize, of course, the amount of code that we put in here. And we have our catch. In this case, I'm using the general type exception, and we'll talk about that in a little bit. And we catch that exception, and we handle it in some way. And then we have our finally block, which will be executed regardless of whether we make it through the try or if we have an exception that we catch. And the finally block is used to clean up any resources that we opened within the try. So let's talk about creating exceptions. What we would like to not do is this. We would like to not put some kind of statement that might cause an exception and essentially handle that, in air quotes, by putting in a try-catch block. And then, if I know that there's a possibility of this object being a null, saying, oh, I'll just catch a null reference exception. And this is a pretty simplistic example, but the theory remains, if I know there's a possibility of a particular type of exception, I should actually try to avoid having that exception happen. Because going into that catch block is a real performance hit. If you've ever stepped through the debugger and stepped through an exception, you can see the tremendous delay that the code has. So there's a lot of problems in actually causing exceptions that you could actually detect without throwing an exception in your code. So in this case, let's look at an alternative that I would recommend. Just simply check if the object is null. If it isn't null, well, then you can call it and do something on it. Otherwise, you handle the null reference. And in that else, it would be really, really good if you didn't just throw an exception. We'll talk about that next. So in this example, we're going to try to avoid throwing an exception. Now this method is a void method, despite the fact that it says getCustomer. So we have a getCustomer routine that returns nothing, and we pass in an int customer ID. And we're not happy if the customer is equal to a null after we've run this code that looks for the customer. And we're going to throw a new exception that says our customer is not found, and therefore our calling client has to handle the exception. We don't know why there's not a customer ID or an invalid customer ID. We're just going to throw it back out to the client and let them figure it out, and perhaps tell the user, oh, you entered in a bad ID or username. But we really don't want to throw an exception because, again, we have a performance issue here. So instead, we'd like to change this method to return a Boolean, perhaps, and check to see if that customer object is null. And if the customer object is null, return false. Otherwise, return true that we actually did find a customer. This is a very similar pattern to what Microsoft did with try parse. In the old days, there was no try parse, there was just parse. So you could do an int.parse and put in a string that was not an integer string, and it would throw an exception, and you'd have to handle the exception, which was obviously bad. A try parse, as you know, returns a Boolean, indicating success or failure of the parsing operation. And it has an output parameter for the value of the output of the parse. So that's a much better pattern because it does not throw an exception. And you can handle anything if you have an invalid string input into that parse. So this is that same kind of idea where we're basically doing a try get customer. The basic idea is we want to minimize the amount of exceptions that our application ever throws. Try to catch specific exceptions instead of using that generic exception object. You'll have better performance, and you'll be able to provide more specific exception handling because you'll know exactly what that exception is. Also, don't rethrow the exception. There's a performance hit in doing so. It basically doubles the penalty that you're paying on catching an exception. If you really have to rethrow the exception for some reason, rethrow the same exception object. That way you're not creating a new exception and you're not doubling up on that performance hit. The other reason is that if you create a new exception and then throw that, you'll lose all of the stack trace information that was in the originating exception. And that could be valuable information if you're logging the exception into some sort of log or event viewer. Try to surround as little code as possible in a try-catch. Number one, that means that there are very few lines of code in your application that you believe can even throw an exception, which may be a good thing, or slightly delusional, hard to say. But more importantly, it's a performance issue. The fewer lines of code that you have within a try-catch, the better your performance will be. Also, don't ignore exceptions without any notification or logging, basically having an empty catch block. You're essentially covering up something that's wrong. If there's an exception in your code, that means that something unexpected happened, and to just not do anything and not be aware of it is not necessarily good form. I know we've all done it before, myself included, but really think twice before you ever do that. It's also good to avoid putting exception handling inside of loops. And this is another one of those things that it does happen, and you do have to do it on occasion. But overall, you'd like to surround the loop in the try-catch, and you get better performance out of that. But there are times that you need to continue on with the loop and catch and just log the exception and keep on going with the other items within the loop. And that's understandable, but only do that when you really have to. So those are some guidelines for some exception handling. And do put some thought into your exception handling when you're creating your applications and your classes and your methods. It'll pay off for you in the long run and create a lot less headaches for you. If you've gone through all the Gang of 4 design pattern lessons and seen the 23 patterns, you may be wondering, what happened to the MVC pattern? Well, the MVC pattern is extremely well used, but it's actually not a Gang of 4 pattern. But it is really important, so we're going to spend a number of lessons working on it. MVC stands for Model View Controller, and it's a design pattern actually created in the 70s by Xerox, so it actually predates the Gang of 4. And it's used in ASP.NET since 2007, and it's extremely well used today. It's actually more of an architectural pattern as opposed to a design pattern. We typically think of design patterns as smaller portions of an application describing interrelationships between classes. MVC actually describes the entire architecture of the application, and it breaks it up into those three pieces: model, view, and controller. The model is essentially equal to the data, and that data can come from anywhere. It can come from a database, which is often the case, a business layer, which may also talk to a database, but the business layer itself would be the model in the MVC pattern, or just a simple view data. Perhaps it comes from an XML file, or just a text file, or it's just an object that is created. The view is the user interface, and the controller processes requests, operates on the model, and renders views. So it's basically taking user input, working on the model or the data, and sending that model to the views so the views can be updated and their display can be updated to reflect any changes that happen in the data model. Here's the classic diagram of an MVC design pattern. We have the user down bottom, and starting with a user action, the user is going to provide some sort of input that will go into the controller, and that's where that user uses the controller. In response, the controller will manipulate the model in some way. It may call for a new model worth of data, in other words, a query, or it may update the model. Either way, it's going to have to do something with the model in response to that user action. When the model is updated, it'll be sent to the view, and the view will update its user interface elements. And then the user, of course, will see that update. So you get that complete loop. It says, okay, the user is going to create an action. It'll go through the controller, which talks to the model, which talks to the view, and gives the user some visual feedback. That's the classic pattern. The MVC pattern is used well outside of ASP.NET, but we're going to be using it specifically in ASP.NET for a while. So the model works a little bit differently, and there's some details that ASP.NET adds to it. So in our ASP.NET pattern, we have our user out to the left creating a URL request. Anything the user does whether it be click on a button, enter text into a text area, or click on a link, creates some sort of URL request, whether it be in background or for a page reload. That URL request goes into our view object, and our view object translates that request into a URL for routing. ASP.NET has the idea of routing, so we don't specifically call out page URLs, we call out more often folders. The routing will route into our controller class, and our controller can have responses to a number of different actions that the routing provides. It can be the initial view of the page itself, but it can also be in response to different button actions within that page, and also AJAX requests. So the controller can have a number of routing interfaces. The controller will then talk to the model, which may indeed talk to a database. It doesn't have to be hooked to a database, but it commonly is. And it will do any queries, updates, inserts, deletes, whatever is the appropriate response to the user input. The model will then send any updates to the controller, and the controller will pass those model updates to the view, and the view will send out the response. In fact, often the controller is passing an instance of the model to the view, so it's a little bit of a pipe through on the output side. So why do we have a model view controller anyway? What good does it do? And it seems like maybe it's nice that things are separated, but does it add any complexity? Well, that's the really important part, is there's a separation of concerns. So the data is handled completely in the model classes, actions are handled completely in controllers, and user interface is completely handled in the views. So I have that separation, which means that I can have a data model and a controller, and they can handle different types of user interfaces, which is really important when we're talking about mobile versus desktop platforms in today's world. So that separation is really important. It adds discipline to our code and also adds maintainability. That separation also adds a bit of simplicity to the code. For the same kind of reasons that you've seen when we go through the Gang of Four pattern, we're often trying to create a separation between our application code and other features or functionality. And we create separate classes to do that. And it helps our code become more maintainable because we have smaller code modules and they're not coupled as tightly to each other. The MVC pattern does that as well. The model, controller, and view are not very tightly coupled at all. So changes within the data model typically won't hurt anything upstream in the controllers or the views. So that really helps the maintainability of our code. It also simplifies our code a little bit because, of course, we're not doing the three functions in one big lumpy application code that possibly turns into spaghetti. So let's talk about the pieces. We have the model, which is our data storage class. And the source of the data doesn't matter. It can come from a database. It can be a business layer. It can be responses from a web service. It can be file reads, or it can just be data that's created in memory on the fly. Doesn't matter what the source is. In terms of use in the model view controller, the model isn't particularly active. It doesn't do a lot, whereas the controller is the thing that actually does things. So in ASP.NET, the controller inherits from system.web.mvc.controller, and it will contain public action methods. And those methods may be for the initial page load, or they may be in response to any sort of user input on that page. There are associated configurable URLs associated with the controller, and the routing system will point and translate URL requests into those URLs, which will in turn call controller action methods. And we'll see how this works when we get to actual code examples. Those action methods will process and then return a view object, which typically is a data model. Our view primarily presents the user interface, and that's really its only job. The early MVC versions actually used ASP.NET Web Forms, ASPXs, for the view. In MVC 3, Razor was introduced, and what Razor does is it allows code within HTML. This is sort of like the old server-side calls in ASPX. So as you'll see, we can actually do for loops within a data collection in order to generate HTML. So if you remember the old ASPX repeater control, that's extremely easy to replicate in Razor without actually having to do a control. So that's the basic idea behind the model view controller pattern and the way we're going to be looking at it in ASP.NET. There's some terminology and technology that we also want to take a look at, and we'll be doing that in future lessons. Before we dive into the code, let's take a look at some of the common terminology and syntaxes used in MVC projects. They're not specific to MVC actually. They're more .NET technologies, but they're used an awful lot in the samples that you'll see in MVC. First is the way objects are initialized. Rather than creating a customer object and calling out new customer and closing the statement, and then setting each property by calling customer.company name .owner name, often we create new objects and then within curly braces initialize the properties. There's not really any difference in the way the code runs. It's just a little bit of a different and more simplified syntax. So you can see in the example, we're creating a customer object and we're setting the company name and owner name properties, sort of during the construction of that object. It's not technically during the construction, however, because the constructor in this case has 0 parameters. And you can tell that because we're using a curly brace there. If it had parameters, we'd have regular parentheses with the parameters inside the parentheses. This is just creating the new customer and then turning around and setting that company name and owner name property. Below it, you can see how we're initializing a list of strings. This may be a little bit more familiar to you. It's the same way you would initialize an array. And we can do dictionaries basically the same way by putting the key value pairs in curly braces and then putting the curly braces in an overall set of curly braces for the dictionary. So you can see in this example, we're creating a new dictionary, which is a templated dictionary, which has a string key and an integer value type. And then we have for our first key value pair, the string key and the value 5. And then the second one has the string key 2 and the value 25. The var keyword is also used a lot. In this case, we're doing that same kind of constructor that we did before for the new customer, except instead of typing customer as customer, we're just putting in var. Now, some people seem to think that this means that it's untyped. That's not true. There's an automatic type inference, and that inference is at compile time. It is not at runtime. So that if you actually attempt to assign this to a different type of object, you will get a compile time error. So the var is understood in this case that it is a customer object. So it's not untyped, and the compiler understands it. So you won't have those kind of errors in terms of type mismatches. If you're thinking, sort of like the old untyped VB, that's not what it is. Now, I'm not a big fan of var myself, because if I actually know the type, I'd prefer to just see it. But you'll see it a lot in MVC examples. We also have anonymous types, and this is where var is actually handy. So in this case, we're creating a customer. However, we're not giving our object a type. We're basically creating this type on the fly. So it creates a little small storage class. And it will handle whatever types we put into those properties. So if I had another property there, for instance, for customer ID, and I put in the value 5, it would understand that that was an integer. So we can actually type the properties as well, but there just isn't really any kind of class name associated with it. This isn't something that you're going to want to pass around your application. It's really more of a temporary thing, and it's often used in response to JSON requests. So in response to an action, and I'm sending out JSON, I can create this little object and send it down in JSON. And the JSON won't really care about the type. It only really cares about the properties and the property values. So again, this is still strongly typed in its own way, and so I can't assign it to a different type of object. So it is still strongly typed at compile time. We also use Lambda expressions a ton in MVC, and we use them both in the views in Razor and also in the controllers when we're working with data models. And the Lambda expression is in that area of the where clause. So in this case, we're looping through our customers that we're getting from a data context, which is actually going to be our model in our model view controller. And we're working with a where clause. So we're looking to filter our customers where the state is equal to Massachusetts. So on the left side of the arrow operator, you can see the letter C, which is the variable name that matches our customer C. So that C is a customer object. And that's our input into the Lambda expression. The rest of it on the right-hand side is the actual expression itself. So we're looking for the state property on the customer object C, and we're looking for it to equal MA. And we can use and or operations and all sorts of other operators and parentheses, and make relatively complex statements if we want to. So you'll see these a lot, and you'll see them often in conjunction with LINQ. Now LINQ, or LINQ, is called Language Integrated Query. My understanding is that the formal pronunciation is actually LINQ. I don't seem to be able to bring myself to pronounce it that way, so you'll hear me say LINQ most of the time. So here's a LINQ statement, and I'm creating a product list, and it's basically a select statement. So I'm looking to select from my product table, or my data context, which is my model, my products collection, and I'm going to create a new select list item. And I'm going to do that by setting my text property for my select list item equal to the product name and the value of the select list item equal to the product ID. So what you can see is that this is semi-SQL within code. And you can also see it's a little bit backwards because it starts with the from clause as opposed to the select. So just going through it a little bit, we're going from products, and that's just going to be the collection name in data context.products. And then from that, we're going to select and create a new select list item, and we're going to set its text and value properties using the properties on the products collection. So if there are 5 products in that data context products table or model, we're going to end up with 5 select list items. So in this way, we can query within code. And this doesn't have to apply specifically to databases. We can query any sort of object that supports the iQueryable interface. So we'll also work on domain objects, not just data-related objects. Now, this technique can be somewhat controversial because it actually encourages you to put the rough equivalent of SQL within code, which in properly separated concerns is not necessarily a good idea. But you will see it very often in controller code, but not really to operate the database directly. It's really just to do more fine querying on the actual data model itself. So your mileage may vary as to whether you want to use this kind of technique or actually just offload it into some sort of business layer. And your business layer could run LINQ as well. The first time I ever saw it, I didn't care for it for just that reason. I didn't like the SQL in the code. But things change and times evolve, and now I'm much more comfortable with it than I was. But again, it should be in its own place as opposed to becoming more of that kind of spaghetti where you've got LINQ spread all over the application. It should be isolated into business layers or data context layers as opposed to being spread heavily all over your controllers. So that's a little bit of the terminology and syntax that you're going to be seeing a lot in the MVC examples. So now we can actually get in there and code a bit. Let's talk about some best practices when building up MVC applications. Most of these tips will address maintaining each of the MVC layer's responsibilities. That's one of the keys of the MVC, is that each one of the layers have specific responsibilities. And if you've seen the course on Solid, a given class has a single responsibility. These layers also are limited in what they should do. So views should only contain presentation code. There shouldn't be any business logic in them. So there shouldn't be any heavy-duty validation or any of that kind of thing. There also shouldn't be any database queries. The model is the layer that contains the business logic. So it contains the data layer interface, the validation logic, and the business rules. And the controllers are responsible for the input validation, and that's just checking to make sure that the validation follows the correct patterns. For instance, a required parameter, a range check perhaps, or even a regex, but not a complicated validation logic that involves the business rules. The controllers are responsible for retrieving data from the model and returning the appropriate view or redirecting to another appropriate action. So keeping these things in mind, we'll take a look at each one of the layers and take a look at some best practices for each one of them. So for the model, consider creating a model for each view. Don't try to share a model between views. What inevitably happens is one of the views expands, adds a feature, and changes the model. So the model is no longer appropriate for the other view, and you may or may not remember that the other view is using the same model, and you may end up creating a bug because of that. And at that point, you'll end up having to create the second model anyway. So just creating a model for each view will probably save you some time there. You might also consider just using view model classes. And view model classes just do the data binding. They're effectively storage classes. They don't have any logic behind them. And those might be the classes that you use in your views. That doesn't mean that the model as an overall layer doesn't have any validation rules or business rules. It just means that the particular classes that the view uses for the model just are storage classes just for data binding. The model layer as a whole should definitely contain the business logic. So that is the validation rules, update rules, calculations, search algorithms. Basically, the model has a lot of the guts of the logic of the application, really most of it. And in that, you should be careful with individual classes doing too much. Again, going back to solid principles, you want to take a look at single responsibility. And this is another reason why you might consider using view model classes in addition to business object classes. The model should not have any presentation code. You often see where people will generate HTML in the model or the controller or even store it in the database. Please don't do that. I'm actually currently working on a project where HTML is stored in the database. It's not a good thing. In the future, you may need to support different UI platforms, maybe a mobile native application that doesn't use HTML. So now what do you do with the HTML that's in the database? Parse it and figure out something else? It's not good. So put HTML where it belongs, in the view. And consider using a separate assembly for the model. That'll actually help enforce your separation of concerns. Also, consider using the entity framework or LINQ to SQL, and that'll help clean up the code a bit and keep some of the SQL strings out of it. Moving on to the view. The focus of the view is presenting data. Now, this is where the HTML, jQuery, whatever you're going to use in terms of presentation should be. And we do like some complexity to our web pages at times, although that's not necessarily the current trend. But do use shared views or partial views or HTML helpers anytime you see something that's being used relatively often throughout your application. It's the idea of using user controls or master pages or just widgets in general, just reuse of common elements. It'll simplify your page view, and it'll also give you some reuse, so you don't have to go tracing through each view that has a certain feature to it. In your views, try to use the model data as opposed to the view bag. The model data will provide some type safety that the view bag does not. Moving on to the controller. It's a little bit of a dead horse, but don't put HTML in the controller. Don't put SQL in the controller as well. HTML is in the view, and SQL is in the model. The controller is really for managing traffic flow, so HTML and SQL are not appropriate for the controller. Return explicitly named views. By default, the naming convention when you return view with no parameters is /views/controller/action. If I have a products controller and an action called update, by default, my view, when I return a view without a parameter name, will be under views, products, update. That may not be what I want, and it's not explicit. It's a little bit of a magic string, and if I change the action name later on and don't realize that I have a view named that has to be changed as well, that can cause some trouble. So instead, use the return view with a parameter for the view name, and that will decouple that view name from the action name. And remember that view name is the file name of the view. And 404 errors can be avoided a little bit by implementing handle unknown action in the controller. So you can return a default or an error view as opposed to the generic 404 error page. You can also add a handle error attribute on any action and return an error view instead of a more generic 500 error. Also on the controller, you can use a thing called a post redirect get pattern, or a PRG. You've probably seen this all the time. When you're on a web page that is basically doing a post, so you're submitting some data on the web page to the server, and you get impatient because it appears to be hung or something, and you hit refresh, and you'll get that warning about, oh, do you want to resubmit your data? And if you actually do say, yeah, sure, go ahead, then you may be submitting duplicate data. And I'm sure you've seen that a ton in very well-known web pages. One way to avoid that is to use the PRG pattern. And what that essentially does is you return a redirect to action and pass in an action name. This will result in an HTTP 302 or temporary redirect, and it will generate a get on your action name. So the user, if they refresh, won't see that nasty resubmit warning, and you won't get duplicate data. So those are some best practices for the model, view, and controller. Now, this is just to clear up a little bit of confusion that some people have about view bag, view data, and temp data. So we'll talk about view bag and view data first. These two are used to pass data from the controller to the view. They're gone on the redirect, so it's basically a one-shot. The view data is a dictionary of objects, while view bag is a dynamic property. So that means that view data requires typecasting and null checks, whereas the view bag doesn't require typecasting. Null checks are still good. So you might prefer view bag just for that one reason. But remember, these are very, very temporary, which is somewhat ironic because temp data is slightly less temporary than the view bag and the view data. Temp data is also a dictionary of objects, so you need to be concerned about typecasting and null checks, but it's valid for the full HTTP request, which means it survives redirects. It doesn't survive anything beyond that original request, but it does survive redirects. So it's one step more permanent than the view bag or view data. So you can pass data from controller to controller on a redirect or from action to action. Internally, it does use session to survive across redirects, but it is not as permanent as a normal session object. So you still have to use session if you're trying to go from page to page and keep things throughout a user session. So those are the different life cycles of the different kind of data storage that you have available in MVC. And those are some best practices as well. And I hope that will make your life a little bit easier when you're creating those kind of web applications. Let's spend this lesson talking about the design of our applications. I'm talking about design in this case. I'm talking about the overall architecture of the application. First, before anything else, design your app before you start coding. So often we get an assignment and we just start banging away at the features that we know how to do without ever thinking about how the overall design should go together. But that design is really important, particularly in terms of the maintainability and the expandability of the app. If we're going to have to live with this thing for a while, we probably want to design it properly to start. That doesn't mean that you're going to actually spend a lot of time designing the individual classes at this point. What it means is that you're going to start to pick an architecture and choose the appropriate layers. And the number of layers will depend upon the complexity of the application and to some extent the technology you're using as well. Once you've done that, it's also important to decouple your layers so that one layer doesn't necessarily know a lot about another layer, and more importantly, that they don't overlap in their responsibilities. So if you have a view layer, it's responsible for presenting information to the user and managing the screens. None of the other layers should be responsible for that. So if you've got a view layer that uses HTML as its basic markup language, none of the other layers should be creating HTML for you. That should just be a responsibility of the view. When we talked about MVC, we talked about this idea in terms of separation of concerns. It's also essentially the same idea we talked about in Solid in the single responsibility principle of a class. In this case, we're talking about layers, which have multiple classes typically, but the idea is the same. There's still a responsibility for a layer, and we don't want our layers overlapping and stepping on each other for those responsibilities. And when you're designing your application, plan for expansion and feature creep in that application so that you haven't coded yourself into a box. However, don't code for the expansion at this point, just design for it, because the expansion you anticipate today may not be the expansion you actually need tomorrow. So you don't necessarily need to code for it and add complexity that's unused, but you do need to plan for it and create a solid foundation that you'll be able to build off of. So let's talk about some architectures that are commonly used. And we're going to focus on database applications. They're about 80% of the applications written, so it seems a safe thing to do. The simplest that I could think of that's of any use at all is a two-tier application. It simply has a data access layer and a presentation layer. The data access layer talks to any kind of data storage that we have, whether it be an actual relational database or perhaps just a storage file, a configuration file, an XML file. Doesn't matter, just some sort of storage that we're working with. And the data access layer in this case also convert that storage into usable objects. Then we have the presentation layer that will take those objects and work with the user and present them to the user. So obviously, this is only going to be used for very simple applications. There aren't going to be a whole lot of business rules, not a lot of logic or calculations or validations or processes that have to be done. The data access layer doesn't have a lot of meat to it in terms of logic. And you could see this perhaps on a mobile device that's a companion application to some other greater application, perhaps a web application on a main server. And maybe that mobile device's data access layer is actually a remote layer. Three-tier architecture is a lot more common. It's actually a classic. It has a data access layer, a business layer, and a presentation layer. And I'm sure you've heard of this. It's a classic design, and really the drawback to three-tier is the presentation layer may become complex. These days we use so many different technologies in the presentation layer. The data access layer and the business layer, those techniques are roughly the same as they have been for quite some time. But the presentation layer has really evolved. We used to use HTML and maybe a little bit of JavaScript. Now we have HTML and jQuery and Ajax and so many different types of frameworks that go along with those technologies that there's a lot going on in the presentation layer. So the three-tier architecture has given way to some other patterns that we've already seen one of. And that's the MVC pattern, the Model View Controller. I won't spend a lot of time on that because we already have a number of lessons on that. If you're interested in that and haven't seen those lessons, do go back and take a look at those. In the Model View Controller, the model can comprise data access and business rules layers. That doesn't mean that you merge them all together into one big old huge composite class. What that means is just that the model will handle the data access and the business rules. And effectively, there are two layers within that model. The view, of course, presents the data, and the controller manages the requests, queries the model, and returns the appropriate view. It also directs traffic, and this is a distinction that we'll talk about in the next one. The view will ask for an action, and the controller will actually do a redirect if necessary, or it will send it to a different controller or a different view. So the controller actually is a traffic cop to some extent. Our next pattern is a model view presenter, which is very similar to a model view controller, except for a couple of distinctions. As you can see in the diagram, the model talks to the presenter, as a model would talk to a controller, and the presenter talks to the view. And that's about the same as a controller talking to a view as well. However, in this case, the view doesn't know anything about the model, whereas in an MVC pattern, the view actually does have the model as part of its references. Also, note that there's a one-to-one relationship between the presenter and the view. So a presenter can only support one view, and a view only talks to one presenter. The model view controller doesn't make any distinction like that. A controller can support, and often does, support multiple views. So the presenter is going to handle all of the UI events for the view, much like a controller. It'll receive input from the users through the view, like a controller. It'll process the user's data using the model, like a controller, and it'll pass the results back to the view, similar to a controller. But unlike the controller, the presenter is decoupled from the view. They communicate to each other through an interface, and the presenter doesn't manage traffic like a controller. It has that one-to-one relationship with the view. So there is a little bit of a subtle distinction there. Our next pattern is the model view model. In this case, again, we have the same kind of model, and we have a view model that it will talk to instead of a controller or a presenter. And the view model is actually going to be much more chunky than what we're familiar with a controller or a presenter. It does a lot more work because the view does a lot less work. The view often is written in a markup language as opposed to having any particular logic capability at all. It's offloaded to the view model. And the technology that allows that to happen is data binding. And you can also see that the view model has a one-to-many relationship with the view. So a view model can support multiple views. This technology was created for Windows Presentation Foundation, or WPF, and Silverlight. It's used in other technologies now at this point as well. The view model exposes the model data in such a way that the view can easily consume them, and it does that consumption through data binding. So that data is synchronized through binders, and that's two-directional binding, by the way. If there are changes in the view model sees those changes. Likewise, if there are changes in the view model, the view will see those changes. What this allows is the view to become very simple, as opposed to some of our complex views that we see sometimes in a model view controller that have a lot of jQuery kinds of things going on and AJAX callbacks into the controller. Because we're doing this with data binding and often observable collections, our view becomes very simple, and really it's intended to be created in markup language, and that's the way it's done in WPF. A variety of XML is used. So those are some architectures to think about when you're creating your next application. I thought I would take this opportunity to give you a little bit of a primer on Lambda expressions. Lambda expressions are somewhat new, although not overly new at this point, but they were a language feature that was not in the original .NET or C# versions. Lambda expressions allow you to create an anonymous function. The function doesn't have a name or a return type. It basically creates a delegate, and you'll often see this used with LINQ queries. It basically gives you a shorthand way of making an expression for the query, and that allows your code to be a bit clearer and more concise, as long as you understand what a Lambda expression is. The format's really simple. You have parameters on the left side and an expression on the right side of an arrow operator. For example, we have our price parameter on the left side of an arrow operator, and the expression is the price greater than 100. So this is going to return a Boolean indicating whether our price is greater than 100. And we can use that within a LINQ query as part of a where clause. So down here, we have a decimal array of prices, and we're going to get our prices. And obviously that method will give us that decimal array. And then we're going to do a little bit of a query on those prices. So for each price in prices, we're going to say where the price is greater than 100. If the price is over 100, then we'll do something. That where clause is where our Lambda expression is, taking an input parameter of price that we're getting from that for each statement and checking to see if that price is greater than 100. We have an array of products, and we want to be able to find all of the products where the price is greater than 100. So we pass in our parameter p, and as you can see, the variable name can be anything. It doesn't have to relate to what's outside of the braces. It's just a local variable for the Lambda expression itself. So we have our input parameter p, and we're going to look on the variable p at its price property and compare that to 100. Now p is actually going to be a product type because it's taking the output of that products.findAll, and it's taking a look at each one of the products individually and comparing their price to 100. So this line will give us all of the products that have a price greater than 100, and those will be stored in our variable big tickets. So I can use this in conjunction with a where method or a findAll or a find and a number of other LINQ methods. I can also use Lambda expressions as a delegate. So in the example, I'm creating a delegate called tax delegate, and it has a parameter product p. My tax delegate named add tax is going to be equal to the Lambda expression where I take the product p and take its price and multiply it times 1.05. Essentially what I'm doing is adding a 5% sales tax to the product price. And the tax delegate is that Lambda expression itself. So then I can call the add tax delegate, pass it in a product, and I will get the tax price for that product. So this is a reusable delegate, so I don't have to repeat the Lambda expression time after time if I'm going to repeat this code. So I can just reuse the tax delegate as opposed to putting in the Lambda expression for p.price times 1.05. Because as we know, tax rates change. We don't necessarily want to have to search for that tax rate throughout our code. So that's a little bit of a brief primer on Lambda expressions. And I think you'll see them a lot, and I think you'll see them more and more as time goes by. Let's take a look at LINQ. My understanding is that the proper pronunciation is LINQ. I'm going to call it LINQ, however, which a lot of people do. I just can't get myself to actually say LINQ. LINQ stands for Language Integrated Query. And what that means is we can put query in code rather than using SQL strings. And the first time I ever saw this, and I imagine a lot of people's first reaction, and still have that reaction, is that putting any kind of query language within code is not necessarily a good idea. And there's certainly that point of view. You might argue, however, that SQL is going to be in code, whether you put it in a stored procedure or a view, you're still going to end up calling that stored procedure or view. And quite often, you're going to just be putting in straight SQL anyway. It may be down in your data layer in the right place, but it's still going to be some sort of query language. So you can use LINQ instead of using SQL, and the benefit that it gives you is that it's compiled. So you'll get compiler warnings and error messages as opposed to having to wait to runtime to see that you mistyped some SQL. Or worse, that you don't get an error and the query just doesn't do exactly what you thought it did. LINQ also has an advantage in that it doesn't necessarily require a database. It requires an IEnumerable or iQueryable interface on the object that we're working on. So we can work on data context tables, which are going to be typically business objects, or we can work on data tables from a database, which is more like what we would use SQL on, but we can also work on arrays and lists and XML docs. So LINQ is very flexible in the types of objects that it can work with. There are actually two syntax forms for LINQ. The first is a query expression syntax, and it looks a bit more like SQL, sort of with the old HP calculator notation. So we have a select statement here, but instead of the first keyword being select, we start with the from clause. So I say from order in orders, where, and this is going to be the where clause, where order ID is equal to 25, select order. And at the end of that select statement, we can actually create objects so that we select an order and then create a new object based on that order if we want to. So it's a little bit of a funny notation if you're more used to straightforward SQL, but it is still of that form. The other form of syntax is a standard dot notation syntax, where we have orders, which is going to be our collection that we've already established, and dot where, and this is where we create the where clause, and we use a Lambda expression for that where clause. So our order ID has to equal 25, and then dot select, and we again use a Lambda expression. In this case, we're going to return all of our orders. LINQ also provides us one other difference than we might see in SQL. It has the idea of a deferred result. And a deferred result means that we have the statement in code, but the actual query isn't executed until the collection is enumerated. So we can establish the LINQ statement, but it's not run right then when the LINQ statement is established in code. It's not actually run until we take a look at the result collection. So that means that the updates to data are reflected in the results. So if we've created a LINQ statement, perhaps at the beginning of our class construction, but we don't actually enumerate the collection until a user has some sort of action input to us, the user is going to get the benefit of any updates that happened from other threads or other users on that data, because the actual query of the data wasn't run until that user action. So that means the data is as fresh as it can be. We're going to take a look at the number of the LINQ methods. In the table, will indicate whether the results are deferred or not. So LINQ has a lot of methods, and I just thought I would take a look at some of them, and you can go through the table and take a look at the documentation for the others. The all method is going to return true if all the items in the source data match the predicate, in other words, the where clause. And any correlates to all a bit, but it'll return true if at least one of the items in the source matches the predicate. So this is sort of an and or an or logic. We also have a contains method, an account method, and a first method, and those are all fairly self-explanatory. And because none of those actually return an enumerable collection, none of them are deferred. You'll probably use first or default really often. First or default is similar to the first method in that it returns the first item from a data source, or if there aren't any items, it'll return no items. The first method that does not have a default will throw an error if there are no items. And then of course we have last or default. And we also have min or max. And that will return either the smallest or the largest value specified by a Lambda expression. So these are all fairly simple and obvious from the method names. We also can do order bys. And order bys by default are ascending, and we can use the keyword descending as well to reverse that, same as you would in SQL. And that is one of our deferred queries because it actually does return an IEnumerable. It returns a collection of objects that we're ordering. And there's a reverse method that reverses the order of items. And probably the one that you'll use the most is the select. and we already had that in our example. It simply returns a result set from a query. Single and singular default are also methods that you'll probably use a lot, because they'll return a single item. So if you're running a query on a table, for instance, you're looking for an item based on its primary key, or some other query string, and you only expect one return value, you can use single or singular default. Single will throw an exception if there are multiple matches, as will singular default. Single will also throw an exception if there are no matches, whereas singular default will return a default value. And the default value, by default, is equal to null, unless your object says otherwise. We can also find our way in collections by using skips and takes. So a skip will skip over a specified number of elements, and a take will take a specified number of elements from the start of the data. So take is a rough equivalent of a limit. So if you just wanted the top 10 results, you could do a take. We also have an aggregate function called sum, and it simply totals the values selected by the predicate. And we do have methods for converting our collections into arrays, dictionaries, or lists. And of course, we have where clauses. And along with the select, you'll probably use the where just about as often. And often in the where clause, you're using a lambda expression if you're using that dot notation. So that's an overview of LINQ, and I think you'll see it a lot these days in C# code, particularly if you're working with ASP.NET MVC projects. I've created an ASP.NET MVC project in order to show you LINQ in a real project. It's going to be pretty simple, but it should give you an idea of how to use LINQ and what it looks like when it's actually being used within an MVC project. So we're going to have a Northwinds entity database, and that's hooked to a live database, and we're going to be using that for our queries. Our first page will be an index page, and for our first query, we're going to query the products table. So we go to our Northwinds entity database, the products table, and put in a LINQ where clause. And here we're using a lambda expression to find out whether the unit price is greater than $50. And then we'll select that product, and we'll get all the fields in the product. And that's what that last select P arrow P is. It's a lambda expression to show that we want to return the full product object. Once we have the products, we'll return them to the view in a toList. Taking a look at the view, we're looking for an IEnumerable of type product, and that will be the model for our view. And then we're just going to display it in a table, the product name, quantity per unit, unit price, all the fields in the product. So we have a display name, and that's going to be the field name, and then the rest of the rows are for each one of the products in the model. And again, we'll take the value of the product name, quantity per unit, etc. Down below, we're going to have a couple of action links, and we'll take a look at those later. So let's give this a quick run, and we'll see the products that we have that are over $50. And as you can see, the unit price is all over 50. And the table isn't sorted in any way, but it does give us all of the fields that we had asked for. Going back to our controller, let's switch that query a bit. And this time we'll use an order by clause. And now we want to order by descending the unit price. So in this case, we don't have a where clause, so we're going to return all of the products, but we are going to do an order by on it. So now we can see all of the products, and you can see that we have products that are under $50, and we have an order by descending on the unit price. So that was what we wanted as well. And for our last run on products, we'll do a take. And the take is basically a limit. So we're going to take the top 5. So we're going to use that order by descending on unit price, but we're only going to take the top 5. So this will effectively give us the top 5 in unit price. And there we go. Just 5 records in descending order by unit price. Okay, so there are our products. At the bottom of that view, we had a couple of action links. One was for categories. So we'll continue looking at LINQ by taking a look at the categories. And what we'd like to do is we'd like to get a count with the categories. So we're first going to do a select distinct, meaning that we're only going to look for distinct category IDs in our products. So we get a list of categories that our products actually use, and they'll be distinct, so we're only going to get one per category. And we'll return that list in our view. We'll also get a category count, and that will be done by going into the products table and selecting our category IDs, distinct, and using LINQ's count method. And we'll put that in our view bag. And here's what the view looks like. Our view bag, which we have the category count in, we'll simply put as a label up top in a div. And then we'll have a table for each one of the category IDs in the model. And the model is just IEnumerable of int, because we only got the category IDs. So we're just going to have a list of numbers in this table. So you can see in our select clause, we didn't select the entire product object. We only selected the category ID field. So that's why we're only going to have an integer. So this is our old products query, and we'll go to the action link for categories. And here's our category count and the category IDs, which cleverly count 1 to 8. So it doesn't tell you a lot, but it gives you an idea of how you can use LINQ in that kind of query. Now, we probably would have been more interested in the actual category names that were used as opposed to the IDs, but that would require us to have a join. So in this next example, we're going to create a join, and we're going to do it on the orders table and the customers table. So here's our LINQ query, and this time I changed away from the dot syntax. So I'm going to have from C in DB customers, so that'll be from our customers table, join O in DB orders, so that'll be a join on our orders table, and we'll join on the customer ID equal to the customer ID in both tables. Then we'll put in a where clause where the freight is greater than $25 from the order table, and we'll order that by the freight descending. So we've got quite a lot in that LINQ statement going on. We've got a join, we've got a where clause, and we've got an order by. Then in our select, we're going to create a new object. So we're going to create a joined order object. And in our model, we created a joined order class that's simply a storage class, and it stores order ID, customer ID, shipped via, freight, company name, and contact name. And note the use of nullable. So in our select clause, we create that new object and set the various properties using the objects in the LINQ query. So for order ID, I get it from the order table. So for the order ID, I get it from the order object O.orderID. For the company name, I get that from the customer object C.company_name. So this is the way I can use the joined tables and create a single object out of them. And then I'll simply return a list of those orders. So let's see what that one looks like. And here's our action link for orders. And here we go, the order ID, the company name, contact name, which comes from customers, the ship via, and the freight. You can see the freight is descending and all the way down, but not below $25. So that was what we were looking for. So that gives you some basic forms for LINQ in an MVC project. And of course, you can use these same techniques in other project types as well. There's nothing particular about MVC in these LINQ queries at all. So you can use it in a web service, for instance, or even a Windows Forms project. So take a look at that, and I think you'll find LINQ is a pretty useful thing. The ability to run async methods has been out for a little while, so I hope that you're familiar with it. If you're not, you're really going to like it if you do any sort of threaded or long-winded operations and want to avoid your user interface locking up. Async can be and often is used in conjunction with await, and it's used for long-running tasks that if you ran synchronously on the UI thread would block the user interface and basically give the impression that the application was locked up or frozen. And that gets users frustrated, and they shut things down and reboot and do all sorts of bad things in the middle of your long-winded operation. Async actually uses a different thread than the main UI. Now, of course, we can use multi-threaded and have been able to use multi-threaded programming for ages, but it's a little bit of a pain to construct. Async simplifies that tremendously. So we can use async with await, and our UI can remain responsive, but our structure is actually still very much like a synchronous method, and we don't have to do a lot of eventing and callback and all that kind of stuff. So it's really easy to implement. So taking a look at the old thread method, and this was about as simple as it gets in order to be able to fit it on a slide. So I have a method called start process, and it's going to start some really long-winded thing. So I create my thread object, and I create a new thread and give it a new thread start with a worker method. And then I call on that thread the start method, and that will run the worker method in a different thread. After I call thread start, this method will immediately return back to the main UI. So my main UI is responsive, and my worker method is working on a secondary thread. That's great. That's exactly what I want. But here's where it gets more complicated. You'll note that my worker method has no parameters, and it has no return type. It also doesn't have any obvious way to go get back to the main UI thread. So I have to fire an event or call a control invoke or something crazy like that makes my code a little bit awkward. I can use parameters, but I have to format them in such that they end up in delegates. I can't just do anything I want. And obviously the return value, well, it doesn't go anywhere, so that doesn't help me at all. So I don't have a return value that I can work with. So there are limitations, and of course there's always ways to get around this, but they're awkward, and they require a fair amount of code that just makes it more difficult to support and a little bit less readable. So let's take a look at a real async method. And this async method will call out to a website and get a response and return the string response. So I have the async keyword up front, and then I have the task keyword with the type string. And that's going to be my return type that I'm going to return a string. And I can pass in whatever parameters I want. So I have the string URL, I create a web request out of that URL, and then I await the response for that request. So I call request.getResponseAsync, which is another asynchronous method, and I use that keyword await. So despite the fact that getResponse is an asynchronous method, if I use the keyword await, it will wait for that to return. If I didn't use the keyword await, it would return immediately, and I would just basically be starting to get that response. By using the keyword await, I avoid some kind of polling loop or callback mechanism in order to get the response. So in that way, it acts like a synchronous method, but because I'm using await, it doesn't block the thread which it's called on. So I get the response to the request, and I run it through a stream and ultimately return the string of that response. So that's what the async method looks like, and here's what it looks like when I call it. I simply have, again, an asynchronous method, get string from web, and string response is equal to, again, await, get web response, and passing in some sort of URL. And I can get that as a string object, and I can directly access the UI. If I was using the old-fashioned thread way of doing it, even if I had a callback from the thread or an event delegate from the thread, I would have to be able to get back to the user interface thread from that secondary thread. So I'd have to do something like a control invoke on a Windows Form application. So it just makes it more difficult to access the UI thread from a secondary thread. Async takes that away, and I don't have that complication anymore. I can directly access the UI with this string response. So that's really simple. The async methods and the task class also supply some other nice little methods. So in this method, we're going to run two tasks asynchronously, and we're basically going to run them simultaneously, and we'd like to wait until both of them are done before we return out of this method. So we create a tasks array and create our two tasks using the appropriate methods that we want to call for those two tasks. In this case, download file 1 and 2. And then we call await task.whenAll and pass in the tasks array. And that will start both of those tasks running, and this will not return until both of them are finished. So if you have, for instance, like this, a multi-file download, and you don't want to return to the user until all of the files are downloaded, this works perfectly for that kind of idea. We can also do a similar thing, but we can get the first one. So if we have two tasks that we essentially want to run in the rough equivalent of a race, we can again create our task array with our two download file tasks, and then use await task.whenAnyTasks. And that will return when the first task gets done. It doesn't matter which task it is, whether it be download file 1 or download file 2. When either one of those gets done, the await task.whenAny will return at that point. The second task will keep on running, but will return from the method when we get the first download. So again, another little variation that can be handy. So that gives you a good idea of what async can do. And there are a number of other methods associated with the task class as well. And you can get to be more complex if you wish. But I think one of the great things that really can be used for async is to attach to remote servers and get responses, whether it be URLs or download files or upload files, because those are the kinds of methods and tasks that take time, and if they're done improperly, can freeze UIs and frustrate users. And they work perfectly with using the async keyword. So do take a deeper look at that as well. Congratulations on taking the whole course. By now, you're a C# guru, or something close anyway. So this course was all about writing better code. The intention was to give you some better structures and object-oriented patterns, and some tips on how to make your code more maintainable and more supportable. We also talked about code style, probably too long about code style, but hopefully you can go to your team and you guys can come to an agreement as to what style you want to use that's not too painful for all involved. Then we got into something a bit more interesting, some solid principles, which of course are some object-oriented principles that you should be familiar with, but just kind of put in a different way, in a different perspective. And it gives you a nice quick checklist because there's only 5 principles involved. So you can kind of review your designs and take a look at that in terms of solid. We also gave you a number of general best practices over a number of topics, and we spent some time on exception handling, which no one really likes to talk about, but we talked about it. And then we discussed Lambda Expressions and LINQ. And both of those are Microsoft technologies that are in common use these days, and you'll see them more and more as time goes by. Particularly if you're working in the web, you'll see that a lot in ASP.NET MVC patterns. And we also talked about async methods, which really take a lot of the pain of doing multi-threaded apps. Let's give you some resources to go even further. First of all, we have the book for solid principles, and the website, and the initial paper. So these resources will give you even more information about object-oriented programming and good solid patterns. Microsoft, of course, has a lot of documentation, and they have their own coding conventions, a number of which we discussed. But if you need backup in order to support your team argument about how to do code style, you can use the Microsoft site for that kind of backup. More interestingly, Microsoft also has guidelines and best practices, and they have a lot of technical detail. For instance, when you're dealing with strings and how the inner workings of strings work and affect the efficiencies of strings. And they cover, of course, a tremendous amount of topics all across the framework. And then another resource you might be interested in is a classic book called Design Patterns, Elements of Reusable Object-Oriented Software. And it's not a .NET specific book. As you can see, it was written in 1995 before .NET even existed. But it's an object-oriented design pattern book, and it gives you a lot of nice little reusable patterns that you can use throughout your designs. There are 23 of those patterns, and they're really handy. A lot of things that you may be doing just by your own intuition, but this will give you some academic rigor to it, as well as give you some other ideas that you might not have thought of. We also, of course, have a video course in it, if you're interested in that. So those are some resources. Happy coding!